Good morning, everyone. I hope you're all enjoying the summit and getting a lot out of it, or at least the coffee is good and you're enjoying that. So it's an honor and a privilege to be standing in front of you today, especially talking about something as critical as security and something as complex as security at scale. So whether you're breaking out of your first sandbox or you're already deploying complicated applications across multiple VPCs and multiple accounts, me and my team, we've seen it all, and we're here to help. So without further ado, let's get started. So in true Amazon fashion, we're going to start with you and the challenges and objectives that you guys face every day. We're going to talk about security in the cloud and of the cloud, as well as do a quick overview of some AWS security services which directly affiliate to large-scale applications and deployments in AWS. But even more important than that, what I want you to take away from this session is a deep understanding of your security on AWS, as well as the security of your workloads, and understand how to gain that visibility, and even more important, use that visibility to perhaps automate some remediation. So your challenges. So NIST, the National Institute of Standards and Technology, created a cybersecurity framework, which is a voluntary framework that highlights the security best practices for workloads. So could you do me a favor and raise your hand if you're upheld to NIST standards? That's a good amount of you, yeah. So even if you aren't familiar with NIST, you're probably following their standards anyways, just a little bit behind the scenes. And whether you're an app developer, a network engineer, or true InfoSec, everyone should be paying attention to this framework. And luckily for us, we had a few great Amazonians who took these 5 pillars and mapped them directly to AWS services to make things easy for you. And if you are upheld by NIST, there actually is a CloudFormation script that you can run, which will create a NIST-compliant environment for you at the click of a button. So who here has to deal with continuous diagnostics and mitigation, CDM? I actually had somebody approach me about this yesterday, and in fact, we are working on an alignment for this as well, but this deals with everything from what is your data, how you're protecting it, who's on your network, and what's on your network, and how to see diagnostics and mitigate any changes. What about ISO? Who here has to be ISO compliant? Less people, but again, these are standard security practices, and you might be practicing them behind the scenes. So the AWS shared responsibility model. Hopefully you've seen this before. I'm not going to ask for a raise of hands. If you haven't seen this before, please come see me after class, because I want to talk to you. So again, we're responsible for everything from the physical layer all the way up to the hypervisor, and then the customer is responsible for the OS and up. And then, of course, this line changes. I believe the most responsibility in which AWS takes on is Lambda, but that line goes all the way up. So here are a rundown list of all of our services which help you with security. Some of these services are only security related, so literally only dealing with security. So identity and access management, of course. The thought of having least privilege first is definitely a best practice. And even in the IAM console, if you're not aware, you can actually see a list, drill down to the user and see a list of products that they're using and the last time that they've accessed it. So if somebody has access to recognition and they've never used it, maybe take that access away. Or they have access to S3 and they haven't used it for 8 months, maybe consider taking that access away. As well as things like GuardDuty. GuardDuty revolves around security only, and we're going to talk about that as well. Something that we're not going to talk about is Amazon Macie, which is great for data in which you store in S3 buckets. We will find any PII or PCI data just by doing a quick scan of your entire bucket, and you choose which data you wish to scan. We also have Amazon Inspector, which is vulnerability scanner that you can scan within your EC2 instances in your VPC. And those are services that are directly correlated with security. And then we have other services that can be used for multiple things, like Lambda, that you can leverage for security. So let's get back to this. These are the 5 pillars of the NIST standard: identity, protect, detect, respond, and recover. So we're going to go through how our services map directly to these. Identify. So these are the instrumentations in which you can identify things. And what's an instrumentation? So when you drove your car here today, or any day, if you were driving down the road and your oil was low, you wouldn't know your oil was low, but you have an instrumentation in your car in which will tell you your oil is low, and then a light will pop on, and you'll say, oh, something's wrong. This allows you to identify what's going on in your environment and allows you to take action. So I'm sure some of these services are very familiar to you, and if they're not, there's actually additional slides which are hidden that I'm not going to go over today, and once we disperse the deck, there's additional slides with additional information about all of these services. But Amazon CloudWatch, of course, monitors instances and services, CPU, disk utilization, network in and out. CloudTrail is our API audit trail, in which stores every single API in an S3 bucket. And if you're familiar with AWS, you know every single call to your environment is an API call, even if you're in the console. So all of those calls are being stored in S3. Amazon GuardDuty, which we're going to deep dive in a little bit later, is in the middle here, because it's basically its job to identify any changes or detect any malicious activity within your account. Amazon Inspector, which I spoke about earlier, and then AWS Shield, which is your protection against DDoS attacks if you have a public-facing web application. Amazon Macie, and then also VPC flow logs, which we'll get into a little bit later. Next is protect. So IAM, and within IAM, KMS, is your first line of defense to protect against any insider threats, and also encrypt your data to protect your data. And of course, it's best practices to encrypt your data wherever it is, in transit, at rest, etc. We want you to encrypt everything. Amazon EC2 Systems Manager, we're going to do a deep dive in. WAF is our web application firewall, that is fully managed by us, and it actually works very well with Shield to protect against any attacks for your public-facing applications. We have Certificate Manager, which will help create and store certificates for you, which AWS manages fully, as well as the general concepts of VPC, security groups, and access control lists. So all these pieces come together to create a protected environment which you have control over. You control the boundary, how the traffic interacts coming in and out, and how to mitigate any DDoS attacks. So detect. So this essentially would be the light on your dashboard which comes on when your oil is low. So Amazon CloudWatch, which we spoke about earlier, has CloudWatch events, which will help notify you if there is an issue. You can hook CloudWatch events to SNS, our simple notification service, which will text you, SES, which is email, and along with other services. SES is mentioned below. CloudTrail, again, will let you know if any user is doing any sort of questionable activity, all the way down to if a user is trying to log in with the root password, or if the user is trying to log in without their MFA token. And you can automate a response on that as well. You can be notified as well as shoot off a Lambda. Amazon Inspector, again, vulnerability scanning, Macie, GuardDuty, all of these are here to help you detect changes within your environment, whether they're good, bad, ugly, these tools are here for you. So respond. So here's where it starts to get interesting, right? So we have AWS Config, which is basically like an audit trail for all the changes that have been made to a specific resource within your account. Configs have rules, which you can automate to be pushed to CloudWatch events and then be pushed to Lambda. The special thing about AWS Config is that it is directly integrated with SNS. So you can create SNS topics directly from config. Unlike our other services, which utilize CloudWatch and CloudWatch-based events. The system manager we're going to get into, but it's fantastic to detect any changes within your configuration and to push down compliance. And then WAF and Shield, again, for any DDoS or any firewall, application firewall issues. And going back to CloudWatch and the event-based rules that you can apply there, basically CloudWatch is our event bus. You can push all of these services through CloudWatch events, and even highlighted in red for events for services not listed. So if you're not familiar with CloudWatch, you can actually create custom metrics to push to CloudWatch and CloudWatch logs. So you can even create responses to application failures as well. So here's a laundry list of what CloudWatch covers out of the box, but it's highly customizable, so you can create events on whatever you'd like. And recover. So automated remediation is, I think, what makes AWS special. And as you can see, we've got a lot of Lambda up here. If you're not familiar with Lambda, it's our triggered compute. So basically, it's just code that fires off at a notification, whether that's an S3 entry, a CloudWatch event, which is highly covered here, or even scheduled. So you can do step functions with Lambda. You can have an SNS topic fire Lambda, as well as a CloudWatch event. So service callouts. Amazon GuardDuty. Is anyone here familiar with GuardDuty? Okay, I got a couple hands, that's great. We announced Amazon GuardDuty back in reInvent of 2017, so not too long ago, back in November. And we built this off of a customer need. So we have all these fantastic services, and we have all of these logs in which we're collecting about your data and about your environment, which we make available to you through flow logs and CloudTrail events. But our customers came to us and said, hey, we really appreciate all these things that you can offer to us, but we really don't have the time to build an actual tool to ingest all of this data and then remediate against it and create dashboards against it. And so GuardDuty came about. And what it will do is it will detect reconnaissance, instant compromise, and account compromise within and outside, coming from outside into your AWS environment. The data sources include VPC flow logs, which is basically the internet traffic on an ENI, or an elastic network interface, and includes the source IP, the destination IP, the number of packets, whether it was accepted or denied by the security groups, et cetera. DNS logs from our DNS service, Route 53, as well as CloudTrail events. All CloudTrail logs are also gathered by GuardDuty. And it will detect and notify you of any findings. I believe reconnaissance is blue, or hey, it's informational, hey, this is going on. That would be something like a port scan. Yellow and red are depending on whether it's suspicious activity or it's a true compromise and to act. So what are the service benefits? This is a laundry list of the great benefits of GuardDuty. And what I can't stress enough about GuardDuty is how easy it is to use. So all you need to do is go into the console and click Start. And GuardDuty will automatically start running within your environment. You can also connect and master GuardDuty to other accounts. And what I've been seeing with my customers lately is that they'll have an actual security account that's dedicated to only the information security officers to log in, to check logs, to check on compliance, et cetera. And they will have GuardDuty running in that security account and interact with all the other accounts from this account. So you can have multiple accounts connected and a one master account which is receiving all the data, which I think is fantastic. And again, it's so easy to use. It's literally a click of a button, and then you're in, and everything is being scanned. You can receive results in minutes, hopefully not. The more results you receive, the more in trouble you are. I have GuardDuty running in my own account, and I have a web server running, and about every so often, every couple hours, I will get a notification that a known vicious host is scanning my ports because I have port 80 open to the world because I'm serving a website. That's a sort of like a blue topic, so it's just informational, but it's really interesting to see. I've also sort of run scans against my accounts and had other things pop up. But hopefully when you turn on, the best day to turn on GuardDuty is the day that you know everything is safe and your alerts are very low. So taking GuardDuty to the next step is being able to use CloudWatch events and then trigger Lambda in order to do automatic remediation or automatic incident response. So depending on how you configure it, you can configure it to respond to everything. But a very common practice is to have a CloudWatch event, and if an instance is compromised by any means, to go ahead and isolate that instance, to snapshot the EBS volumes and share a copy with a forensic account or a VPC. And that can all be done while you're sitting at dinner, enjoying your dinner. You get a notification saying, hey, GuardDuty detected a compromise, and you say, oh, okay. And then you get another alert 5 minutes later saying, hey, that instance has been isolated, and your snapshots are now ready in your forensic account to take a look at. And you know your environment is safe. Here's an example of my console. Again, a lot of it's just informational. There's some sort of suggestive yellows in there. But again, this is what it will show you. It will show you the actor IP address, where it's coming from, whether it was blocked, et cetera. And it really is as easy as turning it on and receiving these results. So Systems Manager. Another excellent service that we have which works across accounts. So again, you can have this running in your security account, monitoring all your accounts as System Manager. It has a laundry list of capabilities which allow you to monitor your resources as well as push down compliance and rules and patch your resources. And how this works is when you open up Systems Manager, you'll get a dashboard. You can add as many accounts as you'd like. And you go ahead and you create groups of resources, whether that's EC2 instances by application, S3 buckets, et cetera. And then you can see all the metrics for that group. And you can see, oh, hey, there's something wrong here. I see these metrics are going, this instance is running hot, or something's wrong with this instance, it's not receiving any traffic, et cetera. And another thing that's great about Systems Manager is you can actually use it in hybrid mode. So you can use it on Windows and Linux in hybrid mode and actually install the agent on your computers and servers on-prem as well and have it report back to Systems Manager. And all of this is at no additional cost. Well, while there's many reasons why you should care, here's a list of a good 6. We really want you to be able to automate repetitive tasks. And one of my favorite things about Amazon Systems Manager is Run Command. So if you have a very traditional infrastructure with servers that you need to SSH into to install updates and patches, that's a thing of the past with Run Command. You can just set up some sort of patch that you want to push to a group of servers and then go ahead and run it, and the agent will do it for you. So you're taking another step away from having to SSH into boxes and treating them more as disposable products instead of members of the family. Along with that, there's also a parameter store to keep your configurations and your parameters separate, whether that's encrypted or passwords keys, etc. We have a parameter store that's available to you. You can also set up a maintenance window and many other things. AWS Config is an amazing service if you get audited. So you can turn on AWS Config and it will start logging all the changes that are being made to your services in your environment. And what's fantastic about Config is you can drill down even to the security group level. So let's say I have a web server security group and for some reason somebody opened SSH to the world at some point. I can actually go back, look at that individual security group, bring that up, and I will see a timeline of all the changes that have been made to that one specific resource. So like May 7th, 3 things happened. I can drill down into that. I can see what happened and who made the change. Also, AWS Config will send you directly SNS notifications, and all the history is captured in snapshots in S3 buckets. So we've discussed a lot of topics here today. The shared responsibility model, of course, is at the frontmost. Visibility and insight through that identify group, seeing resources, seeing what they're doing, et cetera. Consistency, we're actually going to go more into automation and infrastructure as code and CI/CD, but also cloud formation, making sure that your environments are consistent. Again, everything here will help you audit. Everything is mostly actionable and will allow you to create automation for either remediation or spinning up new accounts, et cetera. Separation of concerns, that's the blast radius of what you're affecting, hence maybe having a completely separate account for security and having security being able to look into all the other accounts without actually having to log into the environment. Least privilege first, always. If someone doesn't need access to prod, don't give them access. I am your friend. Make it as least privilege as possible. Again, secure your data in transit and at rest with encryption using KMS, Cloud HSM, whatever you choose. And practice game days. Have game days. Don't rely on one remediation. Don't rely on one service. Have game days which will actually go through what would happen if you were attacked, if something was compromised. Run through your remediation. Make sure it works. And then also have defense in depth. Keep adding layers. Never stop because the bad guys don't. Okay, now I'm going to have Adrian join me on the stage. He's the star here, and here's your clicker. Enjoy.
Thank you. Morning. How is everybody this morning? Has everybody had coffee yet this morning? I've had a lot of coffee, and I'm from New York, so I talk really, really fast. So apologies. All right, so I'm here. I'm Adrian Monza. I'm from United States Citizenship and Immigration Services, and I'm here to talk about a tool that we've built called Cloud Monitor that we've used to migrate from DevOps to true DevSecOps. And if the clicker, there we go. So let's talk about our story. Our story probably sounds a lot like your stories. It starts with rapid adoption. We got an account, we started putting things into it, and life was good. We started migrating more and more applications. We found innovation. We started doing things like blue-green deploys. We adopted immutable server models. We were doing zero downtime deploys, things that I never imagined as a federal employee that I'd ever seen. That I would ever see. I was accustomed to, like, you deploy every 6 months. Okay, no, actually. You deploy every 9 months. No, actually. You deploy every year and you're doing well, right? All of you have probably been there, right? But we went from that to we're deploying, in some cases, multiple times a day. It's absolutely amazing. So we've got speed. Features are going out that are getting out. We're just a success upon success upon success, and life is fabulous. But there was a dark side behind it. And the dark side was the 3 problems, the 3 S's I call them: scale, sprawl, and snowflakes. So scale, we're starting to push more and more stuff in. When we were on premise, we were limited by the physical size of our data centers, by how much capital, how much equipment we could actually buy. when we're in Amazon, we can just keep moving. We can keep iterating. We can test, see if something works. So the scale at which we're operating is like nothing that we've ever done before. Sprawl, we started adding more and more and more accounts. And Snowflakes, the upside of two-person team or two pizza teams is great. The downside is that everybody tends to do it a little bit differently. So let's go back to the beginning for us. So again, we started with that one account, probably a lot like you. Well, then you better separate prod from dev. That's a good idea. And well, then the next system comes in, and well, I want to have some centralized services, my CI/CD pipeline, my code repository, centralized networking account, and I don't want my systems, it to be in my systems account. I want them to be separate. And before long, it looks something like this. I think at last count, we have somewhere north of about 60 different accounts. And just there's no way to log into all of that to see whether or not everything is configured the way it's supposed to be. How do you log into that and to see whether or not someone's accidentally made your S3 bucket public, or to see whether or not someone's accidentally attached an internet gateway? Can I get some head nods that this has happened to you, that you've been there? And it outgrew our ability to monitor them. We just couldn't do it. We had to change. So what were our options? Well, the first option is we could deploy the centrally managed standardized solution. We will build the one solution for everybody. We'll have everybody log into it, and we'll manage it there. We'll really well control it. But you do that, it's kind of slow. It's very resource intensive. You have to spend that engineering time to build it. You have to design it. You have to deploy it. For us, for the way that we're architected internally as an organization, that was too restrictive. It wasn't a good cultural fit for us. And what about all the stuff that we'd already deployed? How are we going to migrate what we already had to this beautiful solution, assuming that we could even implement it? So that wasn't a good plan. We thought about it, and we looked at a couple of products for it, but we couldn't figure out a way to make it work. So we said, okay, well, here's what we'll do. We'll establish some enterprise standards, and we'll get everybody to follow the standards. Well, that was hard. We really, really tried. We did. We did a lot of documentation. We put it out there, but really, ultimately, it was limited success and limited adoption because we just couldn't, we had no ability to enforce it. There's a lot of those two pizza teams. How do I go out and how do I find every single group of developers and making sure that they're all doing things the same way, that they all have the same level of understanding about the security relevant aspects of the accounts, the security relevant aspects of security groups, of the at least 2 or 3 different ways that you can configure an S3 object. And again, it seems like it'd be scalable. You write the documentation once and you push it out. But because of the communication problem, that's when we discovered it really wasn't scalable. So, with apologies to Devo, how do we solve this? Well, when a problem comes along, you must automate it. Automate it good. So we built this. It's USCIS Cloud Monitor. It is a framework that we've built in Lambda for automated detection, reporting, and enforcement of our key security and operations policies. We didn't want to leave our engineering brethren behind and just focus only on security. It's really, it's enforcement of the best practices. And with Lambda, cloud native, there's no infrastructure required. I have a well-known allergy to servers. I have now started to get an allergy to even EC2 instances. I don't want to patch them. I don't want to manage them. I run the vulnerability scanning team. I have seen how you all patch them. I don't want to do that. I want to have somebody else do that. Let Amazon do that. Now, what's the key about this? Well, for one, I had to solve that problem of multiple AWS accounts. So we built native multi-account support via cross-account roles. The plugin sits in a central account. The plugins, the Lambda functions, sit in a central account. They receive a CloudWatch event They use the handler to parse that event, and then we'll take on a role to do the detection, the reporting, or the remediation. And one of the cool things is we essentially built a framework that's reusable. So that plugin model, we can build a plugin for anything that there's a CloudWatch event for. And as Jillian was so nice to identify earlier, there's a CloudWatch event for darn near everything now. So let's talk about our initial use case. Our initial use case was kind of a CDM use case. We called it our EC2 tagging policy. We had lots of people spinning up lots of EC2 instances, and sometimes those people that spun up those EC2 instances would leave without turning them back off. So we wanted to know really simple things. What is it? Who administers it? So when I need it to be patched, who do I call? And what FSMA boundary? What system is it in? What FSMA boundary? So we had this as a policy. This was one of our enterprise standards. And as I mentioned, less than ideal compliance rates. And that's a real security concern. I don't want things on my network that I don't know who owns them, that have questionable patching at best, that have questionable security. This is not a good best practice. But at the same time, I don't want to just go shut things off and cause outages. That's not a good plan either. And let's face it, from an operations standpoint, it's also kind of expensive when you have all of these things running that nobody's using anymore. So again, our automated solution. So we looked at that and we said, well, if you're not tagged properly, that's a glitch. You're no longer in compliance with our security requirements. So we fixed it. So our tagging policy, every single time a instance spins up, it sends an event to CloudWatch events. We then take that, we pull the do a EC2 describe to get the tags for the instance. And if your instance is non-compliant, we will helpfully stop it for you until you bring it back into compliance. We're helpful that way. So we did a gradual rollout. We were nice. Lots of communications to the teams. We started with that detection and reporting. So we just started with reporting via SNS. Hey, if we were enforcing this, we would have stopped your instance. Please go fix it. And then we did that for a while, and we started with detection and enforcement in our non-production accounts. And it took some getting used to. We stopped a couple CI/CD pipelines. We had a couple of very unhappy developers when things didn't deploy as they anticipated. But we got over that. And eventually, now we're running it in production. And I will tell you, I think somewhere north of 400 instances now that we've stopped permanently due to this. The savings on this are I'm comfortable with saying they're in the tens of thousands. They're probably in the hundreds of thousands of dollars yearly just from this type of policy. And this is just one of them. So let's go, again, this is just a use case for one of the things that we've built into this framework. And so now we have 100% compliance. How do I know we have 100% compliance? Because if it wasn't compliant, it's not running. Immediate feedback. If someone accidentally forgets a tag, they get immediate feedback. It stops them before they have the opportunity to really work on that instance, to do whatever it is, to install the software. It just stops it cold. Basically, we use the idea of breaking the build. We've broken the build. And so what do you do when a build's broken? You go back and you fix it. Significant cost savings. This has been so successful. We started with EC2. We've now extended it to our RDS instances. And actually, we've even extended it to on-premise. We saw that this was such a good idea doing it in AWS that we actually extended our Active Directory schema just so we could do this for all of the field servers that we had at our local field sites. So, again, full disclosure, we did have some hiccups. So a developer kind of forgot a tag when they were doing a blue-green deploy in production. I am happy to tell you that if Lambda gets in a fight with autoscaling wins. Eventually, you will hit the API limits on Lambda, and it will say enough, and autoscaling will win. So we did not have a production outage. But again, overall, great success. So here are some of the current capabilities that we have in the tool. EC2 tagging policy, I've talked a lot about this. We have standardized enforced logging configuration. So things like CloudTrail. We enforce that your CloudTrail is turned on. If you turn it off, we will happily turn it back on for you. We enforce which bucket it goes into, that centralized security account that Jillian talked about. We have one of those, and that's where all the logs go across all of the different accounts. Again, if you happen to change that, if you get it wrong for whatever reason, we fix it for you. ELB logs, VPC flow logs, all of the logs go there, and we can just enforce that now across all our accounts. From a Cloud Monitor perspective, the only thing we have to do is add the fact that that account is an account that we want to add enforcement to and make sure that we have the roles, and it does it itself. An S3 public bucket and object check. So if someone accidentally, maliciously, on purpose makes a S3 object or bucket public, we helpfully, accidentally, not really enforce that, no, it's not going to be public. I will tell you that this has saved our bacon a couple of times. Required security groups. So how many people here have to do vulnerability scans? Okay, yeah, everybody, right? How easy is it to do vulnerability scans if someone's kind of forgot to open up the security group to your vulnerability scanners? So again, just real simple things, right? When a system spins up and changes state, we check the security groups on that system to verify that our scanners can reach it. One of my favorites, we built an environment light switch, our EC2 scheduler. So at 7 or 8 or 9 o'clock at night, we turn off all of our non-production environments. It's just something built into the tags. We just extended that tagging policy. So there's no more, will the last developer please turn off the lights? We just turn it off and save the money. We've also done a lot with IAM best practices, and these are some things where we're not doing enforcement, but where we're utilizing that plug-in framework to do the detection and the remediation. So here's where we're moving. Enforced encryption across all of the things. So when you create an S3 bucket, an S3 object, SQSQ, EBS, et cetera, we'll check and verify that you've encrypted that with KMS. Enforcement of CMK rotation. Automated configuration checks to make sure that RDS is configured correctly how we want it. Also operations, snapshot deletion for unneeded, unused snapshots, removal of unused EBS volumes, and a couple other things. And my favorite, blocking internet gateway deployments. And with that, Jillian? There you go.
Adrian, Monza. Thank you. Okay, so we have about 10 minutes for questions. But again, if you are interested in at scale, please stick around. The next one will be CI/CD, and a few other ones, governance and management, if you're interested in those as well. If you've missed them, they'll be on YouTube eventually, so you can catch them there. Please fill out your surveys. We appreciate your feedback. We need to be able to iterate on it. And yeah, thank you so much. And we have about 10 minutes, so if you want to ask me or Adrien anything, please, I think we have a mic right here, and reach the mic. And you, sir, have a question?
Hey, good morning. Got a quick question. I appreciate all the rundown of all the services, but I noticed that CloudTrail was noticeably absent. So what are your thoughts? Right. What are your thoughts, especially for insider threat detection? How's that fit into your model? And if Adrian can also comment on how you guys have incorporated that into your process as well. Thanks.
If you thought that CloudTrail was absent, I apologize. CloudTrail is definitely a tool that you need to be utilizing, especially for insider threats. CloudTrail will capture every API call that is being made. It will capture the user, where it's coming from, whether that's Elastic Beanstalk, the console, the CLI will give you information on where it's coming from as well. And that's automatically added into GuardDuty. And Adrian, do you have any notes on CloudTrail?
Just from our perspective, CloudTrail is absolutely required. That's why we actually built it into Cloud Monitor to enforce that it's on. We have all of the CloudTrail API event actions going into our centralized logging, and our security operations center has developed a large number of alerts to look for specific API actions. So absolutely, CloudTrail is fundamental. You absolutely have to have it turned on.
Yes.
I guess. With all of the services that you discussed earlier, with respect to compute, storage, and bandwidth or performance, who incurs that penalty, or is that incorporated within the costs? Is it done out of band, or does it impact the actual customer, so forth?
So are you speaking to a specific service or all around?
All of them are either looking at network data in real time, they're storing logs, there's processing involved, especially when you mention, I think it was GuardDuty that potentially does machine learning. That all has obviously a penalty, and I'm just trying to figure out who incurs that, or where's that actually absorbed.
So GuardDuty does have very specific pricing around how much log storage you're storing, either in S3, as well as how many gigabytes of like DNS and VPC flow logs it's ingesting. And I'd be happy to talk to you more about the pricing as well. It's also available on the public documentation, but we're trying to make it as free as possible because we never want price to be a debilitating factor in security. We want to make it as free as possible. For example, like Amazon Macy, which will scan your S3 buckets, you just pay per scan, that's it. So you can scan it once. If the data never changes, you can never scan it again, but once something is added, it will do another scan. That's how that pricing works. So the pricing does differentiate, but we're trying to make it as least expensive as possible because we want to provide it as a service to you. We want you to be able to use it, and we never want cost to be a factor in that.
Thank you.
Yes.
Hi. USCIS seems to be fairly mature in their implementation of this. I was curious for agencies that aren't as mature and are fairly new on our AWS implementation. Do you have any published information on how you went through the security process, how you started setting all this up, like GitHub repos or anything that that sort of documents this that other agencies might be able to leverage?
Absolutely, and we can talk offline.
Okay.
What I would tell you is one of the keys that we've found to increasing that maturity is through the use of things like Cloud Monitor, where you're setting up those guardrails, and that makes our compliance and auditors a lot happier and more comfortable with the way that we're set up and at the speed at which we can move, because we can show them that it's impossible to run off the road, at least in specified ways. So yeah, absolutely, I could sit down and be happy to sit down and talk with you more about how we've done some specific things and answer specific questions.
Thank you.
I think you're next.
You can go. It's
So when you mentioned what you had done for automating all the work in Lambda, how much of that, you called it a framework, are you open sourcing it in terms of reuse, or how much of it is in-house proprietary that?
Our goal is to open source all of it.
Okay, thanks.
Yes.
So both Lambda and GuardDuty are not FedRamped yet. What's the timeline for that? Because I got a bunch of Python scripts that I'd love to move to Lambda. My compliance department won't let me do it yet.
So for roadmap details, I promise everyone here, if you're a customer, you have an account manager and a solutions architect, please reach out to them. You and
Okay.
me, we can connect outside.
Thank you.
It is on the roadmap. Stay tuned.
Hi. Is any of your services as a capability do CVE-based detections?
I'm sorry.
CVE, common, the NIST publication of the vulnerabilities.
Oh, CDE,
CVE.
CBE,
Yeah.
CVE.
Yes.
Oh, I'm sorry. So
That's fine.
my apologies. So we have a few of those which will interact with common vulnerabilities, and they're constantly being iterated on. So both GuardDuty and Inspector are constantly being iterated on. Not only do they leverage, especially GuardDuty, machine learning in order to build a baseline for your account, in order to alert you to any abnormalities, but they're also constantly being updated with known vulnerabilities. So whenever you do a scan or GuardDuty detects compromised, those lists are constantly being updated. Yes?
One more. Can you talk to any notions about GuardDuty for GovCloud and FedRAMP?
GovCloud, yes. So GuardDuty is definitely coming to GovCloud. I would expect it very soon. As far as FedRAMP goes, so we submit a product for a FedRAMP to the JAB for an ATO, and that process can take anywhere from 4 to 6 months. So it is a process. So the general flow of things is it gets pushed to GovCloud, it sits there, and then it is submitted through the FedRAMP process.
Right, so needless to say, it hasn't been submitted in
It
the
has
most
not
recent
been-
submission.
Not
So
for FedRAMP High, which I think that you are.
for GovCloud, yeah.
Yes, not yet. But you can expect it in GovCloud very soon, and you can test it out in some of your sandboxes.
Okay.
And then it will be submitted, and you can expect it sometime
Thanks.
soon after that. Yes.
Image across all the accounts, like a gold AMI, or do you open it up for the project teams to pick one from the marketplace, or how do you enforce that if you do?
So we actually don't use a gold AMI. That is a deliberate decision on our part. And the reason that we don't do that is it goes back to that immutable server model that I alluded to earlier. We have a number of teams whose CI/CD pipelines take in an AMI, build the code, put the code into the AMI, and then seal it, and that AMI, that new AMI, is their new server build. And so we couldn't get into a point where we were whitelisting gold AMIs, because we could whitelist, for example, a base image, but what comes out is going to have a different AMI ID. And so if we didn't have a good way of having teams register what the new AMIs were and keeping on top of that. What we have done is we have created a standardized base image that's hardened that we provide to teams as the input to that CI/CD process.
Okay, thank you.
I think we could probably get people.
Just a quick follow-up on the open source. Do you have a timeline?
I don't have a specific timeline. We definitely have some cleanup internally that we're trying to file some of the rough edges off, but it is something that we are definitely working on.
Any questions? Thank you guys
Thank
so
you.
much.